So we're going to talk about the upcoming test towards the end of the class, right? If you go to Brightspace, you're going to see that I have posted, a review guide, okay? The review sheet, is just indicative, okay? It indicates you what type of problems could be there. But of course, you are welcome to practice as many problems as you could, right? The review sheet is only a few selections, okay? If one wants to be really, really ready, you have to do in each topic you have to be a bunch of practice, right? A bunch. Okay, then we're going to talk about the test towards the end of the class. But today we're going to continue on this chapter 3, right? So last time, it's been a week, okay? So the math class has been a week. If you do not, if you leave it alone, it's very easy to forget when you leave the material alone, right? So I hope everybody is trying to do the my open math, etc. So last time what I have seen is, if I want to distribute, x minus 5 parentheses x plus 5. We said last time there was a shortcut, right? So we don't have to distribute. We can go straight to the answer. What was that? Do you remember?
Multiply?
You see that you can go ahead, take our time and distribute, right?
Minus 5 squared.
Exactly. That is a shortcut. This is a formula. A minus b multiplied by a plus b is a squared minus b squared. We said this is x squared minus 5 squared, right? Which is x squared minus 25. And if you go ahead and you do the math, you're going to find the same answer. Okay? If you have 3x plus 5, let me change, plus 6 right here, and then 3x minus 6. If you do the shortcut, what you gonna get?
$9x squared. Minus 6 to the second power?
Yes, that is absolutely correct, right? This does match. It does match a plus b parentheses a minus b, right? It does match that, so it is a squared minus b squared. This is the difference of two squares. Going to be 3x to the second minus 6 to the second. And when you square 3x, you have to square both of them. You have to square the 3, and you have to square the x. It's going to be 9x squared minus 36, okay? All right, so we did that last time. So now we can go ahead and continue briefly. So square of a sum and of a distance, right? A difference. So basically, we're going to see this stuff right here. A plus b squared, right? There is a formula for that also. This is anything we square is a plus b times itself, right? Everybody agree with that?
Yes.
Everything you square is that multiplied by itself, okay? So now, if I don't know the formula that we're going to see later, I just go ahead and FOIL, right? So you bear with me. So what is a times a?
A.
A what? A times a is a.
To the second power?
A to the second power, thank you. And then what is the next? The next arrow is a plus a times b, right?
A.
Plus ab. And the next arrow is also plus
BA.
plus BA. Can we say BA and AB is the same thing?
No.
No. Yes.
Okay, I mean, do that with regular numbers. When you say 5 times 6, how much we get?
30.
30.
When you say 6 times 5, how much you get?
30.
30.
30.
Okay.
So does it change? It is the same thing, right? So we can say AB also. And then plus the last one here, which is plus B squared, right? The two in the middle, aren't they like terms, these two in the middle?
No.
AB, AB, they are exactly like terms, right?
Oh, well, I thought you had the AB and the second one as a power. So that's side
No,
by side.
no. This is just me having a bad handwriting.
Okay.
Yes, it's just AB, right? Okay, just AB. So these two in the middle, they are like terms, right? So we can group them. So how much we get? We get A squared plus how many of them? When you group them, AB plus AB, how much it gets you?
AB for 4.
You see, don't overdo it. When you say 1 apple plus 1 apple, how many apples?
2. 2.
So 1 AB plus 1 AB, how many ABs?
It would be AB squared.
2.
No, you see, when you say AB squared, it means you are overdoing it. When we add like terms, since they are like terms, we just add the numbers up front.
Okay.
It's going to be 1 plus 1 is 2. 2 what? 2AB. That's it. Remember last time we said adding numbers does not change the power. Do you remember that?
Mm-hmm.
Last week, we said
yeah.
when you add terms, if you add them or if you subtract them, it does not change in any way the exponent. It does not. When you multiply, it could change the exponent, right? But when you add, it does not change the exponent, okay? So this is just 2AB plus B squared, you see? So basically, we have this perfect square. This is a perfect square. A plus B squared is A squared plus 2AB plus B squared. Now, what is the advantage of knowing the formula? The advantage of knowing the formula is going faster. You see, if you know the formula, if you know the end, you don't need to distribute if you know the end. And the end is easy to know. Look at the terms. When you say A plus B squared, what you get? A plus B squared. What is the first term? Is the square of the first one, right?
Mm-hmm.
Plus what? 2AB, which is you multiply A by B and you multiply by 2, right? Twice, 2 times the first one times the second one, right? Okay, plus what? Plus B squared, square of the second one. This is a formula. Is it easy to do? I mean, to remember. So if I do this right here, you see, if I do, somebody asked me to do x plus 7 squared, right? If I know the formula, it will allow me to go faster. If I don't know the formula, what I do?
Go slower.
I just go ahead and distribute, right?
Mm-hmm.
If you don't know the formula, then you have no choice but to write this explicitly, right? To distribute that if you don't know the formula. But if you do know the formula, let's write the 3 terms. What is the first one square?
X.
X.
X squared. What is the second term? What you going to do?
Distribute.
You multiply the x and the 7, and then you multiply by. You multiply the x and the 7, and then you multiply by 2, right?
Right.
You multiply the x by the 7, and then you double that. Okay? How much is going to give you? Do the math. Is twice, is 2, times x times 7, right? That is the middle one. What's going to be the last term?
7 squared.
7 squared.
7 squared, thank you. You see? If you know the formula, it allows you to go faster. If you don't know the formula, you have no choice but to do x plus 7, parentheses, x plus 7, and then do the stuff, right? You see, it's going to be x squared plus 14x plus 49, right?
So, okay. So you always do the 2 times, you did 2 times x times 7 there?
Always, always. You're going to be always the middle term. The middle term is what we call the double product, which means you multiply the two of them and then you double that. You multiply by 2. Okay?
Oh, the middle one, right?
Yes, the middle one, only the middle one, right?
Okay.
So if you have 5x plus 3 squared, we don't want to distribute. Of course, if you don't know the formula, what you do again, you write 5x plus 3, 5x plus 3. There is nothing wrong about that, right? But it's going to just take you more time. But if you know the formula, go ahead, write down. I leave you like, about like 30 seconds. Write down what you just wrote here, this right here. Apply that to the parentheses here.
Okay.
All right. The first term will be what? Tell me, somebody. The first term will be what?
Would be 5x squared.
5x squared. Right? How are you going to write it? Do you write 5x squared like that, or what you put?
Parentheses.
Thank you very much. You put parentheses. You see? Okay. The next term, what you're going to have? The one in the middle. What's it going to be?
2 times 5.
2 times 5x, right? Times what?
3. 3
Times
plus 3.
Thank you. It's 2 times 5x times 3, right?
Where
Okay.
are you getting the 2 from?
The 2 is in the formula. Is that 2 here? Okay. The 2 is the 2 in the formula. And remember where the 2 come from? When you distribute the 2 middle ones, remember when I said 1AB plus 1AB, how much it give you?
2AB.
2AB. The 2 come from there, right? Okay. You see, this 2 is always here. This 2 is always here. And then plus the last one. How much is the last one?
3 squared.
3 squared. Thank you. That's it. Now you always have to just to explicit that. 5x all square. Who can tell me when we remove the parentheses, it's going to become what? 5x all square. Who can tell me that?
25x.
Exactly, 25x squared.
Squared,
Don't forget
yeah.
x. Yes. The middle one, how much is going to become?
30.
30x. Thank you. Plus the last one is
9.
9. That's it. If you don't want that, or if you are not feeling this, what you do 5x plus 3 parentheses 5x plus 3. Okay, and then you distribute. You do that. You do that. You do that. Okay.
Where did you get the 30x from? I'm sorry.
The middle term. Let's multiply them. 2 times 5x is how much? Is 10x, right? And 10x times 3 is
30.
30x. Yes, that's the middle term. Okay, so that's okay.
Because I had 5x and then I had 5x in the parentheses plus 3, but I had plus 3 and then I had 5x plus 3. Could I write it like that?
No. The one in the middle is all multiplications.
Okay.
This one in the middle is all multiplications, right?
Okay.
So this is a plus b. If you do a minus b, right here, if you do a minus b square, it's going to be a very slight difference between the two of them. It's going to be a minus b parentheses a minus b, right? If you distribute, you're going to be a squared, right? Minus ab, right?
Yes.
Minus another ab, right? And then the last one, the two minuses make it plus b squared, okay?
Okay.
That's the distribution. Now, the two in the middle, they don't cancel out, they add up. This is negative 1ab, negative 1ab. How many ab's?
2.
Negative 2ab, right? A squared minus 2ab plus b squared. So when we square a minus b whole square, the only difference between the two formulas is the middle term. In the first one is all pluses in the middle. In the second one is minus in the middle. Do you see? But the structure is the same structure, okay? Same structure, but here we have a plus here, because we have a plus here, and here we have a minus here. See, this is square. We have a minus here, and we have a minus here. But everything else is absolutely the same. So if I do this, go ahead. If I do 4x minus, 6 all squared. What are the two terms? Go ahead. I'll let you write it down.
Okay.
Following the formula right here. Following the formula. All right. Who tells me the first term will be what?
I did parentheses 4x squared.
Thank you. That is absolutely right. What is the middle one? In the middle, what you do?
-6.
You do?
I did negative. Well, I did -2. Parentheses 4x. Parentheses 6.
Exactly. Thank you. How about the last one?
And wait. I didn't finish it, but
Plus what? Plus? It's going to be a plus. What? Which one you have to square now?
6 squared.
Exactly. It is a plus. It's not a minus. The only spot where you have minus is in the middle, right?
Oh, okay.
That's the only spot where you have minus. You see, if you know the formula again, it goes faster. If you don't know the formula, tell me what you have to do. No choice. If you don't know the formula, you have to write them next to each other, and then you distribute, right? Now, we learned distribution last week, right? I'm confident all of you know how to distribute. The formula is just faster, okay? So now, if you remove the parentheses, in the first one, you have to square the 4. It's going to be 16x squared, right? How much do we get in the middle?
48.
48x, thank you. And then the plus
36.
36, okay? I just want you to touch to these two formulas. While they are not like, why all the formulas we saw so far, they are not absolutely necessary. Why? Because if I don't know the formula, I can always distribute, okay? So
that would be the longer way.
Yes, but it's going to be the long way. So are they, if somebody does not know the formula, will they be stuck next week? No. They can always distribute, okay? But if you know the formula and you are confident about it, you're gonna you go faster, and probably you're gonna avoid mistakes. Okay. So now we're gonna do something very, very important, right? Which is factoring. Let me check which part of which part.
3.4, I think.
It's 3.4.
I think.
Yeah, I think you are right. So this is 3.4. It's gonna be 3. No, it's gonna be chapter 4.
Chapter 4.
Yeah, it's gonna be chapter 4, 4.1. Factoring using the greatest common factor. That's, we are now entering into chapter 4, right? Which is all about what we call factoring, chapter 4. And 4.1 is factoring using the greatest common factor. What you call GCF, okay?
What was that we were just doing, Professor? Is that
was a special? That was a special product. That's what 3.6. We started last week and then we finished it today.
Yes. Okay.
All right. So factoring using the GCF. So first of all, the word factoring. The word factoring is transforming an expression into multiplications, right? That is factoring. For instance, when I have the number 6, it's 6, right? As soon as I write 6 equal to 2 times 3, I have factor 6. Okay? Because I wrote 6 as something multiplied by something. In the word factoring, we have factors. You see, we say that 2 is a factor of, any element in a multiplication is called a factor. Okay? Any element, any component of a multiplication is called a factor in math. 2 is a factor. 3 is a factor, right? Okay? 2 is a factor. 3 is a factor. So when we say factor an expression, we mean by that transform that expression into a multiplication, right? Transform it into a multiplication. So now we're going to see some methods of that. The first one is just to recognize what is the greatest common factor and to factor it out, right? But first, in the greatest common factor, we have the technical word that is factor. Maybe some of you know what means factor, some of you maybe don't know. So for instance, example, what are the factors of 6? What we mean by that is, what are any number that you can divide 6 by evenly? This is what we mean factors. A factor of 6 is any number that you can divide 6 by evenly. You have no remainder. So tell me, what are the factors of 6? What are the numbers you can divide 6 by?
2 and 3.
2 and 3.
2 and 3. I knew you guys were going to forget the most obvious one. What are the most obvious ones?
1 and 6.
0.
Yes. 1 and 6. You always have 1, and you always have 1, and you always have the number itself, always.
So 6 would be the greatest common factor.
No. When you say common factor, we have to have at least 2 numbers.
2, okay.
Yes, you see the factor of 6. Now, if I say, what are the factors of 15? What are the numbers you can divide 15 by?
3 and 15.
5.
But no, we're going to come as we're going to start with what? 1, right?
1.
1 and 15, right?
15.
15.
3 and
5.
5. If you don't want to forget nobody, you go pair by pair, right? So you see here, look at them too. Look at them. What are the common factors between them?
3.
1.
No, 3 is the greatest one. But what are all the common factors?
Oh, 1 and 3.
The common factors are 1
And 3.
and 3. 1 and 3. Between 1 and 3, who is the greatest?
3.
3.
3 is the greatest. So we call 3 is the greatest common factor. Do you see that? So greatest GCF of 6 and 15 is 3. You guys see that? So, of course, right here, we're going to try to do this mentally. Is it very practical in a test to write all this list of numbers? It's not. You're gonna when you ask you what is the GCF of 2 numbers, you just try to do it mentally. Okay. For instance, we say what is the GCF of 24 and 30, right? You see, if you ask you what is the GCF of 24 and 30, it's going to take you time. If you're gonna waste your time when you write all the lists. Okay? When you write all the lists, it's going to take you time to write the whole list. But mentally, if the numbers are not big numbers, you can do that mentally, right? So everybody, please think about it. What is the greatest number that you can divide 24 and 6 and 30 by?
6.
Did I tell the answer?
Yep.
Yes. Yeah, you see, it's 6, right? Everybody sees it's 6.
Yes.
You see, the GCF between 24 and 30 is 6, right? Because the factors of 24, there are a lot of them. You know, we have a lot of factors which are 1, 2, 3, 4, 6, you know, 12, 8, you know, 12, and then 24, a lot of them. And 30, we have 1, we have 2, we have 3, we have 5, we have 6, we have 10, we have 15, and we have 30, right? And the common factors, they are 1, 2, 3, and 6. And the biggest one is 6, right? But again, I insist again, if the numbers are not too big, you don't have to waste your time writing the whole list, okay? All right, so the GCF of 24 is 6. Now, does it mean the GCF is easy? No, it's not easy. If the numbers are big, the GCF can be challenging. But, you know, don't worry about that. In OAD2, we will not give you like big numbers, okay? So now, let me give an example of factoring the GCF. Factoring the GCF. Are you going to see sometime how simple it is? So if you say 6x plus 15 or 12x plus 15, or hold on, 6x plus 15, I'm sorry. 6x plus 15. You see, what do you see here? What type of expression do you have? Do you have a sum? Do you have a product? Or do you have a difference or a division? What type of expression you have here?
You have addition.
We have an addition. We have a sum. The main operation here is a plus. What factoring means? Factoring means to make the main operation become a multiplication. That is factoring, right? So now factoring the GCF, we are told the method. We are told what to factor. So we're gonna find the GCF. First, we say what is the GCF of 6x and 15? GCF. So now, x here, is x a common term between, do you see x everywhere?
No.
No.
I don't see x everywhere. It means x cannot be in the GCF, right? X cannot be in the GCF because I don't see x everywhere. Now the two numbers 6 and 15, what we said was the GCF?
1.
Now what we said, we found it here. The GCF of 6 and 15 was?
Oh, 3.
3, right? When you say factor the GCF, what you do, this is what you do. You're going to put the GCF here, which is 3, right? You put the GCF up front. You open the parentheses like this. As soon as you open the parentheses, your main operation becomes a multiplication, right? Now you are factoring now. So you can mute yourself if you have noise around you, please. So now what you do now? Since I have put 3 out, okay, let me mute the person who is okay. Okay, since I have 3 out, I have to make it even. So I have to divide everybody by 3. Okay, since I have multiplied 3 outside, I have to divide everybody by 3 to make it even. This is how the factoring works. You put the GCF in front, and then you divide everybody by 3 by the same GCF to make it even. How much is 6x divided by 3?
2x.
What? 2x. How much 15 divided by 3?
5.
5. You see, that is factoring. You see how easy it could be? I'm done. Now, how I check my answer? If you want to check your answer, you just distribute back, right? You distribute and you see if you get the same stuff. Okay? What is that when you distribute? What is 3 times 2x?
6x.
6x. What is 3 times 5?
15.
Plus 15. Does this match the original?
Yes.
So our factoring is good. Okay. So now let's do this now. Let's do a more complete example. So we say 15x to the 5th minus 12x cubed plus 3x squared. We want to factor that. We want to find first the GCF. But what do you see here that you don't see, that you haven't seen before? Is here we have x everywhere, right? So the x will be in the GCF, and we're going to see what power to put on that. Okay, together. But first, if I wanted the GCF, my GCF will have 2 components. It will have a number. It will have an x, right? It will have a number because we have numbers. And we have in x because x is everywhere, right? We agree with that?
Yeah.
Now, quickly, what is a GCF if I consider the first piece of the GCF, which is the numbers, right? What is the greatest common factor between 15, 12, and 3?
3.
3. And here I'm going to tell you something. The GCF cannot exceed the smallest number of them 3. 15, 12, and 3, the GCF cannot exceed the smallest one. At the most, it's going to be the smallest one, right? So if he says the GCF is 30, you're wrong. If he says the GCF is 4, you are wrong. At the most, the GCF is going to be 3, right? Okay, 3. Now, x. What do you think? Which power we have to put on the x?
Square.
Square. Thank you very much. And here you're gonna try to remember the rule. In the GCF, you always put the smallest power.
Right.
In the GCF, if you have the same variable everywhere, you put the smallest exponent, right? Not the highest exponent, not the one in the middle, the smallest exponent. Understood that? Okay, so now I have my GCF. What I do? I say equal, I put the GCF up front, I put 3x squared here, the GCF, that's the GCF here. And then I open my parentheses. I do this. Okay?
Okay.
How many terms I expect to be in the parentheses?
3.
3 terms. Exactly the number of terms as the original. Exactly. In the original, I have 3 terms. Here, I will have 3 terms, right?
Oh, I know this. Oh, go ahead.
Now, how I get them? I divide everybody by this same GCF, right? 3x squared, 3x squared, 3x squared. You see that? So now I just go ahead and divide. What is 15x to the 5th divided by 3x squared? What is 15 divided by 3? It's 5, right?
Yes.
How much you think x to the 5th divided by x squared? What is going to be x to what power?
Q.
Three.
X to the 3rd. Thank you very much. You see, it was in the quiz. Minus 12 divided by 3 is how much?
4.
4.
Oh, yeah, 4x.
4x to what power? To 1 power, right? You
One.
just write 4x, right?
Oh,
If you
right.
wish, you can write 1 if you wish.
Yeah,
Plus what?
confused for a minute. 1.
1x.
Plus
Just 1.
1x or 1 what? 1. Or is it 1x or 1 or 0?
Yeah.
0.
You see, I included 0 just to let you know 0 will never come out from a division, right? It's always when everybody's gone. What's left is 1 left, right?
Okay.
0 can never come out from a factoring. When you divide, you never have a 0, right? Okay, so this is factoring the GCF. I'm gonna let you know. I'm gonna go straight to the My Open Math, right, and get some problems right from the My Open Math, and then
Can you scroll
ask,
up some stuff?
yeah, like this. Okay. Insert this.
Professor, did you put something up yet?
I think his thing went out. You know how you say it goes out?
Oh,
So, maybe.
oh, there he is.
Oh shit!
Okay.
All right. So my internet, which is a BC internet, just let me down. I even didn't know about it. I was talking to myself for 20 seconds. I'm sorry about that. Okay, so I hope it will not happen. So you have these 2 problems right here. So let me put another one, and then I'm gonna go to the bathroom for 1 minute, come back. So
I'm dead.
try to do that. Hold on, I'm gonna add another one from my Open Math, or just
Okay.
this one right here. Okay, you have 3 problems. All right. So if you look at the first one, what do you think is a GCF, everybody?
4.
4x squared.
4x
The
squared.
GCF is 4 for the numbers and x squared for the variables, right?
Yep.
That is absolutely right. Everybody understand that? The GCF is 4x squared?
Yes.
Okay. So now we know we have to divide by 4x squared, everyone. 4x squared, 4x squared, right? And we get what? We get 20x to the fifth divided by 4x squared is how much?
5x to the
X
third.
squared.
To the third. 4x cubed divided by 4x squared is how much?
1x to the first.
1x to the 1 power, right? 1x, right?
What about
And
the
then
X?
plus
7.
28x squared divided by 4x squared is
7.
7.
What if I,
Okay.
what if I just put X though? I just put X. Is that wrong?
Yeah, it's good. No, it's not wrong. It's
Oh,
good. I put the one for you know, that is just
so you had the 3
yeah,
terms.
just indicative. Okay. I have 3 terms.
I just
So
have-
I do this in my open math. My open math tells me I'm wrong. Why am I wrong?
Because
You
the
this,
X is not,
you do this in the test, you get 0. Why you get 0?
as a multiplication, right?
Exactly. Thank you very much. You see, I intentionally wrote this just to make the point, because unfortunately some students are so focused on giving what remains in the parentheses, they forget the GCF up front.
Oh, yeah.
If
Yeah.
you forget the GCF up front, your whole thing is, unfortunately, this answer is wrong, unfortunately. You see?
Okay.
This answer is wrong, so do not forget what?
4x
The
squared.
GCF, exactly.
why is it GCF or x squared?
Because the greatest common factor, if you consider 20 and 4 and 28, what is the greatest number you can divide those 3 numbers by? It's 4, right?
Right.
And if you consider x to the fifth, x cubed and x squared, the rule is to assign the smallest exponent, because that smallest exponent is contained within everybody, right? So that's the rule. X squared is the greatest common factor between x to the fifth, x cubed, and x squared itself. Okay.
I think if you write them out, it will show you, you know, like I write each one of mine out.
Yeah. You know why x squared? Because x squared is contained. Look at x fifth, x to the fifth. X to the fifth, we can break it down. I didn't want to go into those explanations because, you know, it might confuse a little bit. X to the fifth is x squared times what? X cubed, right? So x squared is a factor of x to the fifth, right? X cubed is x squared times x, right? So x squared is also a factor of x cubed. And x squared is, of course, a factor of x squared, right? So if you look at this right here, x squared is the GCF because x squared is everywhere, right?
So it will always be x squared.
Yes, that the smallest exponent is contained within everybody, right?
Okay.
The smallest exponent is contained within everybody. So that's why, but the biggest exponent is not, right? The highest exponent, we cannot put x to the fifth inside x squared, can we?
No.
Can we put x cubed inside x squared? We cannot. But you can put x squared inside x cubed, and you can put x squared inside x to the fifth, right? So x squared is the GCF.
Okay.
All right. So I was saying, don't forget that 4x squared that I wrote in blue, right? Please. If you forget 4x squared, unfortunately, I cannot make your answer right. And every time I grade those papers, you know, it pains me because, you know, I know the student forgot about it, but I cannot make it right. You see? I cannot say, oh, you know, this is nothing. No, it's something, okay? So don't forget that, please. So what is the GCF of second one?
2.
2.
2 what?
X squared.
2x squared.
2x squared, thank you. 2 for the numbers 10, 6, and 14, right? And x squared for the powers. You see, that is my open math. It gives you the same powers, okay?
Right.
That's messed up. It should change a little bit, okay? But my open math is so automatic. Sometimes you repeat the same stuff. Okay, it's 2x squared. So what you have to do, we put 2x squared up front, 2x squared like this,
Right.
and then we divide. When you
Right.
divide, you don't have to write it down. You can do it mentally, right? But you just write it down to make sure. What is 10x to the fifth divided by 2x squared?
5x to the third.
5x to the third. 6x cubed divided by 2x squared?
3x.
3x. And 14x squared, x squared divided by 2x squared?
7.
7. That's it. Okay, look at now the last one. The last one I wrote. What do you think is a GCF?
X.
1x. The
Yeah.
GCF is 1x, is x, right? The GCF is just x. Everybody see that? Why is x?
Yes.
Then I got confused. But I did have X, but then I was confused on this.
Okay, you got x, right?
Yes.
Okay.
Yeah.
That, you know, that's the hardest part. The hardest part is to get x. Okay, now what you do, you put x here up front and you open the parentheses like this,
Okay.
and you divide everybody by x. Look now what's going to happen. What is x cubed divided by x?
X squared.
X is
X squared. What is 5x squared divided by x?
5X.
5x. What is 7x divided by x?
7.
That's it, plus 7. Right?
Wow. I made that so much harder, but yeah.
Yeah, so
Okay.
Got it.
so exactly. So now if okay, let me open the practice test and see what we have in there. Okay, I have, like, you know, this right here in the practice quiz, the practice stuff. So I have this one right here. They are a little bit, you know, they are a little bit more impressive than the one we did. I'm not saying harder, but they are more impressive, and you're going to see why. This is in the
Uh-oh.
all right. You see, yeah, it happens again. You know, I'm sorry about that. Hopefully, you know, it will not, like, you know, I'm in my office at Owings Mills, so I don't know why it's doing this. Maybe it's Teams that doesn't work. Okay, so right here, I would say this is more impressive. Why it is more impressive? Because we have how many variables now?
3.
We have 3 variables, right? But does it make it any harder? I don't think it makes it any harder, right? I don't think so. Because we're gonna apply the same rule for each variable, right? Do you see x everywhere?
Yeah.
So x will be in the GCF. Do you see y everywhere?
Yeah.
So y will be in the GCF. Do we see z everywhere?
Yes.
So z will be in the GCF, and then you apply the same rule. So I let you, like, 1 minute to do this. So write what is the GCF first.
X, Y, Z square.
All right. What is the GCF you think?
15.
5.
5 for the numbers. I agree with that. Everybody agree with that?
Yeah.
5x
Okay.
to the third
5x.
power.
X to the third power because it is the smallest power of X, right? Y to what power?
Second.
Y to the second because 2 is the
The
smallest
lowest.
power of Y. And Z to what power?
1.
Z to the power 1, right? Everybody see that?
Yeah.
That's the GCF, right? So you put the GCF up front, you put 5x cubed y squared z, and then you open the parentheses, and you want to put everybody here, 5x cubed y squared z, 5x cubed y squared z, 5x cubed y squared z, right? The first one, 20 divided by 5 is what?
4.
4. X to the fifth, right? 8 divided by, 8 minus 3, right? Y to what power? The y is gone, right? Y squared and y squared is gone. Okay, the y squared is gone. And this to what power now?
1.
Z to the 1 power, thank you. Plus 15 divided by 5 is how much?
3x
3.
squared.
X to the second. So y squared, what happened to them?
They cross out.
They cancel, they're gone. How about the z's now?
Gone.
They can go to.
Gone.
Cancel 2, so you have only 3x squared in the middle. Plus what? 35 divided by 5 is?
7.
7. What happened to the x cubed?
They cross out.
They cross out. Y cubed divided by y squared is y to what power?
1.
1.
Power 1. And the z's? Gone. That's it. That's my answer right there. Okay. So if you have this one right here, okay, factor this one. How much is a GCF here?
3.
3.
3 for the numbers. How about the variables? 3
X.
3
To the
x
second power.
Yep.
y to the second power, right?
Oh, is that-
Everybody agree with that? That is 3x to the second, 3x y to the second power, right? So we put the GCF up here, 3x y to the second power. Now, my point of asking you this example right here is to see what everybody gonna say is inside the parentheses. How many terms you got inside the parentheses?
2.
2. You see, when I hear 1 term, that is exactly the reason why I asked you this question. Because the GCF happens to be one of them, right?
Right.
The GCF happens to be exactly the second term. So when you put the GCF out, when you put the number, that term out, it doesn't mean you have 0 left. Zero will never come out from a factoring. Zero never comes out from it. The term will never vanish, right? So what's going to happen is when you divide by 3xy squared, and you divide 3xy squared, right? The first one give you 2x squared, right? The second one now, how much is it going to give you?
-1.
-1, thank you. When the two terms match exactly, you have one left. All right, you have exactly one left, okay? So this is factoring the GCF. On the test next week, you will not see something harder than these examples, or not, okay? You will not see something in the test next week that's going to be harder than this example. It's going to be exactly the same stuff, okay? So I ask you to review that until you get familiarized with it. You know, you have 1 week to do so. So now we're going to see what sometimes we want to factor a negative GCF. Sometimes we want to do that. For instance, we say negative 15x plus 3. Okay? So the GCF is what?
3.
3. But because somebody asked me to factor the negative GCF, instead of factoring 3, I'm going to factor -3. Because I was asked to factor the negative GCF. You see, I am asked to do that, right?
Yeah.
If you just tell me factor, it's not obligatory to factor by -3. If you just tell me factor, I factor by whatever I want. I mean, I factor by the regular GCF, which is 3. But if you tell me in the test, factor the negative GCF, right? Please, you have to follow that direction in the test, please, right? If you wanna, if you don't lose the points. When you say factor the negative GCF, factor the negative GCF, which is what? This is -3. So instead of 3, I'm gonna factor -3, right? Everybody see that? I'm gonna factor -3. Now, what is the rule? The rule is every time you factor out a negative GCF, you're gonna change all the signs. And how? Because we're gonna divide by -3, right? You divide by -3, we divide by -3. Look what happens. -15x divided by -3. What's gonna happen to the minuses?
Become
It's
positive.
gonna turn into a positive.
Become positive. Gonna be 5 what?
5 plus
5x. And 3 divided by -3, what is gonna be?
1.
Negative
One.
what?
1.
-1. You see the plus became a minus, the minus in front became a plus. That is the effect of factoring the negative GCF. The effect of factoring the negative GCF is when you do the negative GCF up front, every single sign inside will change. Someone that was positive will change to negative. Someone that was negative will change to positive, right? But the process, otherwise, the process is the same process, right? It is absolutely the same process. So if you pick up an example from the review sheet, right? Let's pick up an example from the review sheet that I have posted on Price Piece, okay?
So the answer to that last question we was doing, was that 3? Or was it -3? Anybody know?
I got
-3.
-3.
Mm-hmm.
Thank you.
You're welcome. Guess we lost them again.
I was gonna say the same thing.
Maybe it's break time.
Amen.
My teams was acting up too.
Yeah, look at like a little beat.
Yeah, I mean, something is going on with the teams, you know. It just kicks me out every now and then. So I don't think it is not, I even don't think it is about the internet in my office. I don't think so. Maybe something, you know, with teams. Okay, so hopefully, you know. Okay, so right here, the regular GCF is what?
We're at
The regular GCF is
2.
2 x to what power?
2.
1.
X to the power 1, right? It's just 2x,
Yeah,
right?
1.
Because this is 1 right here, it's just 2x. So right here, since somebody asked me to factor the negative GCF, you see how you're going to see it in the test. You're going to see factor the negative GCF. So please do not ignore that negative thing, right? So I'm going to put the negative right here just to follow the direction, okay? So I'm going to put negative 2x right here. Everybody did that? And now you go ahead. This is a process, it's still the same process. You're going to still do this, and you're going to still divide everybody by negative 2x, right? Negative 2x, negative 2x. You see that? So negative 10x to the 4th divided by negative 2x, how much is it going to be?
+5.
5
Positive 5x to what power?
to the 3rd.
To the 3rd. 20x squared divided by negative 2x, how much is it going to be?
Negative.
Negative 10 to what x? What power?
To the 1st.
1.
X to the 1st. Thank you. And 12x divided by negative 2x, how much is it going to be?
-6.
Negative 6. Thank you. You see, when you do that, the signs change. So don't rush, please, in the test. Do not rush. Divide by the negative GCF. Please put the negative sign in the GCF when you see, every time you see that question over there, right? So that is, you know, this is when, you know, what you can say about the GCF. So now sometimes now, if you have this now, factor, you know, 3x squared plus 7x plus 5.
one.
Would it be 1 for the greatest common factor?
The greatest common factor, it is 1. At our level here of math, right? At our level, every time the GCF is 1, we're going to say this stuff is prime, something like that. It is prime. When you say factor GCF, this is what you say. This is factor the GCF, right? I didn't say factor only. I say factor the GCF. When you get the GCF is 1, what you say? This is not factorable, right?
So could you say no solution too?
I mean, no solution is usually for solve. When you say solve, right? You see?
Okay.
So we say not factorable, or there is even a math word for that. We call that prime. Like, you know, a prime number, for instance, is just a number that has 1 and itself as factors. for instance, 5 is a prime number because the only factors of 5 are 1 and 5 itself, right? 7 is a prime number because the only factors of 7 are 1 and 7 itself. 3 is a prime number, etc., etc. You see, that is a very math word, prime. So,
I have a question.
yes, go ahead.
What should would we put, or I'm sorry, would either of those answers be acceptable in my open math or?
Yeah, my open math, you know, if they ask you something like that, where it's prime, if you write prime, I think they would ask you to write prime, I think.
Okay.
Okay, so I think because prime is more math, is like a math word, not factorable also. When you have like, you know, 5x plus 9, what is the GCF? Is 1, right?
Yeah.
Because the GCF is 1, we say this is also prime. We cannot factor this one, right? Okay, so that is just to close this parenthesis. Now, there is a second method of factoring that you're going to call factoring by grouping. Factoring by grouping. Let me see exactly what section is that of my open math.
4.2.
It's 4.2, thank you. It's 4.2, factoring by grouping. So, right here, so look right here. If you have 9x squared, parentheses, x plus 3, minus 5, parentheses, x plus 3. Look at this expression right here. Of course, this expression does not quite look like the one we did before, right? But look at this. Do you see something that is common to both terms?
X plus 3.
X plus 3.
Something wearing red. It's x plus 3, right? X plus 3 is common to both terms. Everything that is common, we can factor it. Anything that is common, you can factor it out, right? Okay, so it doesn't matter if it is a single number, it is a regular expression, or if it is a whole parenthesis. If it is common, you can go ahead and factor it out, right? So what's we're going to do? So we're going to factor out the x plus 3 then. The x plus 3. They're going to be what? It's going to be x plus 3, but the process is going to be the same. You're going to open the parentheses right here. And if you want to know what remains, you just cross out the x plus 3s. When you cross them out, what you're going to see? When you cross x plus 3 out, what remains?
9x squared minus 5.
Exactly, the 9x squared. Everybody see what we did? Because when you do the GCF, look, every time we do the GCF, we have to divide by the GCF, right? Don't we? If I put the x plus 3 out, I have to divide everybody by x plus 3. What's going to happen? When you divide, what's going to happen to x plus 3? They cancel out, right? Who remains?
The 9x.
9x squared. If you do the second term, you factor out x plus 3. Who's going to remain?
Minus 5.
Minus 5, right? Okay. So why I give you this example? Because in our next example of factoring by grouping, this will happen. What we did here exactly will happen. So now, let's see our first example, factor by grouping. You see, when you see this word right here, when you see the word factor by grouping, this is a good hint. This is a hint. Somebody is giving you the hint to factor by grouping. So what you're gonna do? So let me give an example again from the review sheet. Okay. Or let me go from my open math. You see. So the review sheet, I'm gonna let you try to do it by yourself. Okay. So right here, let me give this one right here. All right, so it's becoming too much, you know. Okay, all right. We don't do this technology thing. Okay, so we're gonna do this example right here, factor by grouping, right? That is a good hint, because if it was not for the hint, what is the GCF out of all of them? The four terms. What is the GCF?
1.
2.
Is 2 the GCF? Look at, can we put 2 in the first
1.
term? It's only
No.
1, right?
1.
If it,
Yeah.
if it came only to the GCF, we would be stuck, right?
Mm-hmm.
We would be completely stuck because the GCF is just 1, right? But somebody gave me the hint. Told me factor by grouping, which means I'm going to divide these 4 terms into a group of 2, right?
Mm-hmm. So that means you have to multiply.
So I'm going to do a group of 2, and then I'm going to factor each pair. You see, ignoring completely the other pair, I'm going to factor each pair, right? Because likely each pair will have a GCF, right?
Yeah.
Which is not 1. What is the GCF out of the first pair? Here.
2.
What is the GCF? The first pair, x squared plus 4x. Look closely. Only x squared plus 4x only. I'm not talking about 6x and 24. Only x squared plus 4x. What is the GCF?
X.
X. Thank you very much. Of course, for the numbers is 1 because we have 1x squared and 4x. But for the x squared, for the x's, we have x everywhere. We have x in x squared. We have x in 4x. Everybody agree with that?
Mm-hmm.
So the GCF is x. I'm going to factor out it's going to be x. I put my parentheses like this. I'm going to change the color just to make it, you know. And it's going to be what? X squared divided by x is how much?
X.
X. 4x divided by x is how much?
4x.
Plus 4, right? Okay. You see, I'm done factoring the first pair. Now the second pair now. What is the GCF out of them two?
3.
Is it 3 or more than 3?
6.
6.
It's 6.
It's 6 itself, right? It's 6, right? So we're going to put the GCF. You see, that's plus right here, that plus right here. I'm going to report it here, plus in between, plus. So I'm going to factor 6. And look what happened when you factor 6. Magically, who's going to get out here when you factor about 6, divided by 6, divided by 6? Who's going to come out? What is 6x divided by 6?
1.
1x, right?
Yeah.
What is 24 divided by 6?
4.
4.
Do you see magically who came out?
Mm-hmm.
The blue parentheses, right?
Mm-hmm.
Now we have a GCF now, you see? Actually, that GCF was hidden, right? Now we did something, we did the grouping thing, now it comes before our eyes, you see? Now we can go ahead and factor the x plus 4 outside, right? Exactly as we did this example right here, okay? We're going to factor the x plus 4. We're going to put x plus 4 here, and we factor. When you factor the x plus 4, you cross it out. When you cross the x plus 4, how much? Who remains here?
X.
The 6.
When you remove the x plus 4, who remains?
6.
6.
6.
And that's how you factor this one. You see? Now we have our answer. We have our factoring. This is factoring by grouping. Now, good thing for you, when you say factor by grouping, we don't ask you to reorder. There is no reordering. We just factor neighbor by these neighbors. The 2 first neighbors and the 2 last neighbors, okay? There is no reordering. We will not give you examples where you have to reorder, right? We will not give you those examples. It's like the 2 first neighbors, and then you factor the 2 last neighbors, okay? All right, so let's do together this example right here, and we're going to take a break, right? All right, so we're going to do factor by grouping. For this one right here, we say a factor by grouping. Neighbors with neighbors, 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 right? Let's do this one together. The two first neighbors, do not rush. What is the GCF out of the two first neighbors?
1.
1 for the numbers, but for the W's.
U squared.
W squared, right? Everybody agree with that? So when we ask you what is the GCF, you have to say the GCF as well for the numbers, as well for the variables, right? Not only the numbers, you see? Of course, 1 and 6, the GCF is 1, but then W cubed and W squared, the GCF is W squared, right? It's going to be W, you see these two right here? It's going to be W squared. And then I open up my parentheses, small one, right? I divide by W squared. I divide by W squared. How much you have left? What's the W cubed divided by W squared?
W1
is W to the 1 power, right? Okay. What is 6W squared divided by W squared?
6.
Plus 6. Thank you. You see, now comes something very, very important. Look at the two last terms. What is the GCF of them two?
W.
The two last terms, the negative 8W minus 48. What is the GCF?
Negative 8.
Exactly. Every time that sign is negative, every time the second sign here, this one right here, every time this one is negative, please factor out the negative GCF. Don't factor only 8, factor negative 8, right? Every time, okay? If you don't do that, you might not see the same parentheses coming out, okay? If I want the same parentheses to come out, I factor the negative 8, not positive 8, right? But everybody understands the GCF is 8? Everybody understands the GCF is 8?
Yes.
Yeah.
Why W is not in the GCF? Why?
Because it's 8.
Because W is not in the second one, right? So it's negative 8, it's minus 8 here, and then I open up my parentheses. We're going to divide everybody by negative 8, you see? Divided by negative 8, divided by negative 8. What is negative 8W divided by negative 8?
W.
W.
Is W, thank you. And what is negative 48 divided by negative 8?
6.
Plus 6. You see now, the same parentheses, W plus 6 came out, right?
Mm-hmm.
Okay. Who's going to tell me what is the last step? I'm going to let somebody tell me what is the last step.
W plus 6.
So it will be
W plus 6 parentheses, right? And then what I do?
Right. And then the next parenthesis, it will be
What is the next parenthesis?
W squared.
W squared minus 8.
Minus 8. Thank you.
That's perfect.
Right? W squared minus 8. So I'm gonna put here some of them. Then we're gonna take like about a few minutes break, right? So let me see some of them. So I don't know why this stuff keeps going every time I change screen. Okay, so I have this.
On again.
This. Yeah, so I think teams, have a little problem today. I mean now.
They are. Because mine had kicked out too.
Yeah, I think something is going on with Teams. Maybe that's the reason why, at first people preferred Zoom until Zoom started ask for money. So you have to stop that.
Yeah.
Okay, so yeah.
I was saying in my English class with CCBC, they use Zoom and they don't kick them out.
Yeah, maybe they stopped the process. Maybe somebody yelled at them. I don't know, but because last week it was definitely happening. Last week I tried over and over and over. It was happening until I transited to Teams. I say, okay, I cannot deal with it anymore. I have to transit to Teams. But if they did that and then some people in the higher spheres talk to them and say the education community needs that, maybe they backed up. So probably, but now we are Teams. So I think CCBC is officially using Teams. I think so. CC is so we're gonna try to do that. Okay, so you see, you have this one right here. We're gonna factor by grouping, and we have.
Did it go out again?
No, I think I'm still here. Okay, so we're gonna take 5, 6, 7 minutes break, and then we're gonna come back and continue with this factoring by grouping, right? So meanwhile, you have these two for those people who want to work on them. Meanwhile, right? So we have these two, or we're gonna even make them 3 here.
I don't see anything.
You don't see anything? Okay, let me share my screen. Okay, thank you very much for letting me see. All right, I have this. Okay, now you can see my screen, right?
No. Oh, now we
Yeah,
can.
now
Yes, now you can see my screen. Okay, I have another one here. Okay, so we have one example, second example, third example. So we're going to take about 10 minutes break, just to refresh ourselves, and then we're going to come back. Thank you.
Okay, thank you.
All right, so I think, we had some rest. Okay, so now we can go ahead and focus on these problems right here by grouping, right? The three of them, factor by grouping. Okay, so and neighbor with neighbors, right? The neighbors with neighbors. So it's going to be like that. So we're gonna neighbor with neighbor. These two together, these two together, right? Okay, let me, the first one. The first one. What is the GCF of the first pair of terms?
Two.
The first pair of terms, these two terms, x squared y plus 2y. What is the GCF, you think?
Would it be 1?
1.
1, you think?
Maybe.
Look at,
two.
I mean, you see, the GCF is not only about the numbers, it's also about the variables also. You have x squared y plus 2y. If you just consider the two numbers, the first number here, of course, is 1. So the GCF of 1 and 2 is 1, right? But you don't stop there. You also have to consider the variables also. Right? So now I ask you the question again. What is the GCF, you think?
X squared y.
I know how to do it. X squared plus 2.
X squared plus 2, that is the factoring. That's after you put the GCF out. Of these two values, the GCF is y. Okay? It's not x because x is not everywhere, right? What is the only term that you see everywhere?
Y.
The first two is only y, right? What power are we going to put? Of course, the same power. This is y to the 1 power, y to the 1 power. Okay, we did the GCF first. We did the GCF first. But, okay, I was saying, all right, all of you know this stuff. We did all this example on the GCF right here. Do everybody know the GCF here? How it does work? That is very important to know how to find the GCF. If you don't find the GCF, unfortunately in the test, you won't be able to do those questions, right? You have to find the GCF. I thought, after these examples right here, I thought it was clear for us. It's not only the numbers. When you say the GCF is 4x squared, we look at the numbers in front, right? But also we look at the variables also. When a variable is everywhere, if the variable is everywhere, that variable will be present in the GCF, okay? If the variable is not everywhere, then it will not be present in the GCF, okay? So when I consider these two terms right here, only these two right here, okay? Of course, 1 and 2, the GCF is just 1, right? But I don't stop there. The x is not everywhere, right? Is x everywhere?
No.
No.
So x is not in the GCF. Is y everywhere?
Yes.
Yeah.
So y is in the GCF. So the GCF is
So
y.
yx 2 squared.
Yeah, no, it's gonna be y, right? That is only the GCF is only y. So we put y out, and then when we open up our parentheses, we're gonna divide everybody by y, right?
Yes.
Yeah.
Divide by y, divide by y. So how much we get the first one?
1x squared.
1x squared, thank you. It's x squared. And here, the second term, 2y divided by y is how much?
2.
Plus 2, thank you. Okay, so the GCF is y. Every variable that you see everywhere is in the GCF. If the variable is present everywhere, that variable is in the GCF. All right? 9x squared plus 18. Okay, now everybody gonna tell me the GCF. What is the GCF?
9.
3.
2x squared.
It's 9, right? The GCF is 9, right? The greatest common factor is 9. So what I'm gonna put? I'm gonna put plus 9, parentheses, I divide by 9, I divide by 9. So 9x squared divided by 9 is how much?
1.
1x squared, right?
Yeah.
18 divided by 9 is how much?
2.
2. You see, I am midway. Don't stop right here. I have seen in the past students stopping right here. Don't stop right here. I'm just midway. What is the very, very last step? Somebody tells me. What you gonna write after that?
X squared
You're gonna write x squared
plus 2.
plus 2, the common parentheses, which is this one, you're gonna write it out, right? And then you open up your parentheses, right? When you open the parentheses, if x squared plus 2 is gone, who remains here?
Y plus 9.
Y. Plus what?
9.
Plus 9. And then now you are done, okay? The GCF, please, the GCF is very, very, very important in this topic. Since we started the class today, the GCF is very, very important, right? Okay, so you're gonna do this one. I'm gonna let you do this one, everybody. Try to, separate these two right here. You're gonna take care of these two first. What is the GCF? And then you take care of these two. What is the GCF? This one has a small particularity, and you're gonna see it.
5.
You said 5 only?
It's 5x.
Yeah, you see, please don't say 5 only in the test, right? 5x. Because do I see the x everywhere?
Yes.
In the first two ones, I see the x in the first term, I see the x in the second term, so x is in the GCF. And I put the smallest power, right? Which is the first power. So somebody told me the GCF here is 5x, right? It's gonna be 5x. I'm gonna let you tell me what remains here when you put the 5x out.
2x plus
2x plus
2x plus how much?
1.
Plus 1. Thank you. That is absolutely right. You divide by 5x. You divide by 5x. So you get 2x plus 1. Okay? Now look now the second one now. What is the GCF of 2x plus 1?
1.
It's just 1. Since it is 1, the only thing I can do, that's going to make my job easier, is just to say 1, parentheses, 2x plus 1, right? It doesn't, I don't change anything because the GCF is just 1, you see? And I write the one in front just to show me obviously what's going to be the next step. But I don't have even to write the one. The green one over there, you even don't have to write it down, okay? You see? Now, what is the very, very last step now?
Open up parentheses.
2x.
Plus 1, and then we open the second set of parentheses, what you put in it?
5x plus 1.
5x plus 1, thank you. Now, this one over there is a little bit more challenging. I'm going to let you a couple of minutes for everybody to try to do this. It's new, but I think some of you will figure it out.
Crazy.
All right, so, okay, tell me, these two, somebody tell me the steps. What is the GCF out of the first pair right here?
Negative 2x.
Negative 2.
You think so why you say negative 2, 4x squared minus 2x? I mean, you can factor negative 2 if you want, but what is the incentive? What is the incentive of that? Why not factor only 2? Why not factor 2?
Because there's 2 x's.
Yeah, you see here, so we can factor negative 2, but I don't see the reason why we would do that over factoring 2, okay? But we can factor negative 2 if you want to. But the point I want to make, let's factor positive 2, just to get the point I want to make. If you factor positive 2 right here, so we divide by 2, we divide by 2. How much we get?
2x.
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 Minus 1.
I mean, we factor 2x, I'm sorry. It's not only 2, it's 2x. The GCF is 2x, right? You see?
Right.
I was going to the GCF is 2x, it's not only 2, right?
Mm-hmm.
It's 2x. Don't forget the variable, right? It's 2x minus what?
1.
Minus 1. Okay, now comes the point I want to make. Look,
So
every time that sign is negative right here, every time the third sign is negative, you have to factor it out, right? You see, that sign is negative. If I consider these two right here, of course the GCF is 1, right?
Mm-hmm.
But unlike this example where this sign was plus, we just plus 1 here. Here we're going to factor out minus 1, right? That's the point I want to make. You factor out minus 1, okay? You see that? The GCF is 1, right? But
So that becomes a positive 1.
Exactly. So we factor out minus 1 instead of negative 1. So when we do that here, we divide by negative 1. We divide by negative 1. So negative 2x divided by negative 1 is 2x.
2x.
And 1 divided by negative 1 is negative 1, right? You see now we have the same parentheses, 2x minus 1, 2x minus 1 coming out, right?
Mm-hmm.
Okay. So of course, this can happen in the test, but very likely I'm going to give you a regular one, which is more regular than this right here. Okay. So what you have then, you have 2x minus 1, parentheses, this is gone, is 2x, and this is gone, is minus 1, right? And that is the factoring. 2x minus 1 parentheses 2x minus 1. All right. So this is factoring by grouping.
Okay.
It is based on the GCF. So on the test, you will see one of these examples right here. Maybe not the last two ones, something very, very regular, something like that. You see, that is a very regular example, something like that. Okay? Or if you take the one in the review sheet and then you're gonna open up the one is one of them right here.
Can you go out?
From the review sheet. So let me pick, and then it's gonna be our last.
Hey, Professor, can you go back up just a little bit so we can see the bottom?
I know what that means.
I guess he's gone again. Did anybody catch the bottom? I got 5x and I couldn't see the parentheses that were below.
5x parentheses. Oh, 2 plus 4.
Uh-huh.
Okay, there he is. There he is.
And 1.
Okay. So okay, I'm coming back. You know, I just figured out what is the problem. What this team session doesn't like.
What?
The team session does not like me when I share my screen. It does not like. So I go to you know, as long as I am in the main screen, the document I'm sharing, I think it doesn't. But when I go to I shift to another screen to pick up something, then it disconnects me. You see. And right now here is the sharing. The problem is with the sharing. You see now I'm trying to share right here. I'm trying to share, but it is buffering. You see. So I think this whole team sessions. I didn't get it, you know, in the morning. I had like 2 classes on team. I did them entirely with no problem. But now, I think the problem is with the sharing. You see, now I try to share, it's not letting me. It's saying not responding, right? So that is what happened, right? You know. Okay, so probably.
Can you go up to the last problem?
Yeah, I'm trying to share. You know, my computer is blocking me. So.
What was the which? You talking about the 4x squared minus 2x minus?
Yes.
So it's 4x squared minus 2x minus 2x plus 1.
Okay. All right. Thank you.
You're welcome.
Okay. Gotcha.
Okay, so I think I'm back right here. So I'm gonna share. Okay, so you can see. So that was the last screen right here. You got it?
Got it now. Thank you.
Okay, and now we're gonna do this one right here, and it's gonna be our last example in this topic. Again, I'm gonna let you a couple of minutes. Everybody, please try to do that. This come from the review sheet that is on Brightspace. Try to do that. You see, please. All right, so can somebody walk us through the steps, please? These two and these two. Go ahead, please.
So the first one, I got the greatest common factor was 8x.
Yes.
8x, thank you very much. I agree with that. Everybody agree with that?
Yeah.
Yeah.
8x, because the y is not everywhere, right? Only the x is everywhere. So now you open up your parentheses, what you get inside those parentheses?
4y plus 5x.
Exactly, I agree with that. Because 32xy, 32 divided by 8 is 4. The x cancel out, and then we have y left. And here 40 divided by 8 is 5. And x squared divided by x is x. 4y plus 5x. Thank you.
You're welcome.
What about the next pair? What is the GCF?
We got 8x parentheses. 8.
Yeah, the GCF is 3 right here, right?
Yes.
Thank you, it's 3. So I put 3 here. I put plus 3.
Mm-hmm.
And then I open up my parentheses. How much I get inside that parentheses?
4y
plus 5x.
We divide by 3 is going to be 4y plus 5x. Now, I see the blue parentheses is a common parentheses, right? I can put 4y plus 5x, and then what I have the other one then?
8x plus 3.
Thank you very much, 8x plus 3. If somebody has 8x plus 3 at first and then 4y plus 5x in second position, it is the same answer. Okay.
Okay.
That is the same answer. So you see, that is factoring by grouping. And please review those problems. On the test, it's going to be a sample problem that is not like, it's going to be just a regular case, okay? I will not like wait for the test to give you something tricky, okay? It's going to be the same stuff. But you have to review that thoroughly, right? You see, your class is once a week. If you let the math alone, right, for 5 days, 6 days, you will forget everything. Okay? That's just normal. That's just normal, Everybody's working, I understand that, but you cannot let the math by itself for 5 days, 6 days without going back to it. Okay. All right, so now we're going to open up, and this right here is factoring. I think it's 4.3, I think. Factoring trinomials. This one can be even easier. Trinomials with leading coefficient 1.
Uh-oh.
What type of expressions we're talking about? Something like this: x squared plus bx plus c. You see here the number in front of x squared. What is the number in front of x squared? It is 1. We're going to try to see how to factor this type of expressions, how to factor them. And you're going to see at the end, it's going to be very, very simple. But first, okay, let's see an example right here. Somebody asked me to factor x squared factor x squared plus 7x plus 12. You see here, I have no hint, right? The only thing I see is this is a trinomial. It has 3 terms, trinomial. And it has the leading coefficient is 1. That's the only thing I see. Now, let's go through those two methods that we know. The GCF and the grouping. The GCF, how much is the GCF here? Quickly.
1.
Is 1, so the GCF doesn't work, right?
Mm-hmm.
By grouping, all the examples we did by grouping, how many terms we have?
3.
We had how many terms here? All the examples we did by grouping, how many terms we have? No, originally at the first.
We have
originally.
4.
We had 4 because we have 4 terms and we group them 2 by 2, right?
Oh, yeah.
Yeah.
And here, how many terms do we see here?
3.
Only 3.
Yeah.
If I want to do grouping, I have to manage to have 4 terms. This is what you're going to try to do. We're going to manage to have 4 terms, right? How I'm going to do that? I'm going to break down the middle one into two terms. You see? Make it two terms.
Okay.
7x, we're going to make 7x become two terms. Now, we have countless of ways to make 7x two terms, right?
3.5.
We can say 7x is 1x plus 6x, right? You agree with that?
Yes.
We can say 7x is 2x plus 5x, right?
Mm-hmm.
We agree with that? We can say 7x is 3x plus 4x, right?
Mm-hmm.
We can say 7x is 10x minus 3x, etc., etc. You see, we cannot finish the number of ways, but there is one way that's going to help us. All the other ways will not help us. What are the two numbers we're going to choose? And here you have to listen to me. The two numbers that we're going to choose here to break down 7x, this is what's going to verify. This is what they should verify. They should multiply to 12, and they should add up to 7. Okay?
X3.
You
That
see?
would be 3x plus 4x.
Exactly. You see, we're going to search for two numbers, right? For two numbers that multiply to 12. And what is the 12? Is the last one right here, right? Multiply to 12 and add up to 7. Of course, you see, we have to see what are the way to break down 12 into couples that will add up to 7, right? What are the way to break down 12? What numbers you multiply to get 12 and then you add up to 7? Those numbers are 3 and 4, right? So what is the way that's going to help us is the third way. Is the way that says 7x is 3x plus 4x, right? That is the way that's going to help us. So I'm going to rewrite my expression. So my expression will be x squared. So instead of 7x, I'm going to write 3x plus 4x plus 12, right? Now, how many terms now I have now?
2.
I have 4 terms, right?
4.
Now, can I do the grouping now?
Yes.
Now we can do the grouping, right? 2 by 2. The first two, what is the GCF out of the first two?
1x.
1x, thank you, is x. And then we divide by x, we divide by x. How much we get?
X squared.
X squared divided by x is x, right? Plus how much? 3x divided by x is
3.
3. Is x times x plus 3. And here's these two. What is the GCF out of these two?
4.
4. And then we divide by 4, divide by 4. How much we get? X plus?
X plus 3.
3. Now, what do you see in common now? X plus 3 and x plus 4. Now, let me focus on my answer now. Let me focus on my answer. On my answer here, I have those two numbers. Do we recognize them?
Yes.
Aren't they the two numbers we have to break down the middle term?
Yes.
They are, right? Those two numbers, 3 and 4, they are exactly this 3 and this 4. So the question is, why even do this step right here? Why not go straight to the answer? Because once I got those two numbers, they are the ones that's going to be in the solution, in the answer, right? So I'm going to propose users this shortcut. Every time you have x squared plus 7x plus 12 that you want to, you open up your two parentheses like this. It is only fair to put x here to put x here. Can somebody tell me why? Why it is fair to put x here and x as the leading terms? Because x times x is x squared, and we have x squared, right?
Right.
Now I'm gonna pause. I'm gonna say, what are the two numbers that add up to 7 multiplied to 12, you see? And then I go looking in my head. What are the two numbers that add up to 7 multiplied to 12? I go from the multiplication. It's easier to go from the product, right? I say, okay, what numbers make up 12? I know we have a lot of pairs. We have the pair 1 and 12. Does it work? Do they add up to 7?
Yes.
No.
No, do they add up to 7?
No.
Oh,
That was
no.
too quick, right? That was too quick. So they don't, right? We have the next pair is 2 and 6. Do they add up to 7?
No.
No. We have the next pair 3 and 4. Do they add up to 7?
Yes.
Yeah.
So I'm going to plus 3 plus 4. I'm done.
Oh, wow.
You see, this is an arithmetic. This is an arithmetic problem. Now, some people will find those numbers very quickly because they are more used to the arithmetics. Some people will struggle a little bit to find those two numbers, right? You know, from my experience, I have seen students who get those two numbers very quickly, like in a blink of an eye. I have some students, they have to pause a little bit. They have to think about it, okay? But tell yourself, I'm looking for two numbers. When I add them up, I get 7. When I multiply them, I get 12, right? Okay, so right here, when I have x squared minus 2x minus 15. Okay, again, I do this. You see, for this one, please don't do the long way. I don't invite you, I don't advise you to do the long way. This is too long. What you do, you just open up your parentheses like this. You put x here, you put x here, and then you go fishing for those two numbers. They must multiply to what number?
15.
Do we forget the sign?
Negative 15.
They must multiply to negative 15. And they must add up to what number?
Negative 2.
Exactly. They must multiply to negative 15. So I have to go over the pairs that are going to make up negative 15. When you multiply two numbers and you get a negative number, what that means for those two numbers? What is the logic behind it? How are they?
Positive.
One of them is, one of them has to be
Positive.
Negative.
one of them has to be
Negative.
negative. When you multiply two numbers and you get a negative number, it means one of them has to be positive, one of them has to be negative, right? I know that, you see? So now I'm going to go look for the couples. What numbers come to your mind? What numbers you multiply to get
3
negative
and
15? 3 and 5. Everybody will think about 3 and 5. But if I say 3 and 5, if I leave them here without no negative, one of them has to be positive, other one negative, right? Now I have to choose which one you think has to be negative, so the sum will be negative 2. Which one?
3.
The 3 or the 5?
3.
No, the
Are you
5.
sure?
The 5.
No, the 5.
You guys subtract.
Yes, because if the 3 is negative, if the 3 is negative, when we add them up, what is negative 3 plus 5? Is positive 2, right? You see, the negative, the big number has to be negative right here. So the sum will be this, right? Now let's check. What is 3 times negative 5?
Negative 15.
What is 3 plus negative 5? Negative 2, right? So I have, my answer will be plus 3 here, minus 5. What if somebody did x minus 5, x plus 3?
It don't make a difference.
It don't make a difference. Thank you. It's the same answer, right? Do you see this? It is all arithmetics, right? It is all arithmetics. Now you have just to say what numbers multiply to the last one and add up to the middle one, right? What numbers multiply to the last one and add up to the middle one? Okay, let's see an example like this one. So again, it's x squared, you know, minus 13x, right, plus 36. Go ahead. This, try to find the two numbers, right?
Oh, I know what it is.
Try to find the two numbers.
Okay. I got it.
You got the two numbers?
Mm-hmm.
Yes.
Okay, what are they? Can you share? What are they?
X plus 4 and X minus 9.
X plus 4 minus 9. So basically you are telling me your two numbers are 4 and negative 9. Let's check. Let's check. What is 4 times negative 9?
27.
Is negative 30?
6.
X.
Oh, so
Is
it
it
has to be
positive 36? Okay, you see 4, negative 9 is not
Negative
it,
4,
but it's not
negative
very far away from that. What are the two numbers?
-4, -9.
Negative 4 and negative 9. Do you agree with that?
Yeah.
Negative 4 multiplied by negative 9 is 36, right?
Yep.
And negative 4 plus negative 9 is negative 13. Okay, so this is x minus 4, x minus 9, or vice versa, right? You see here, I don't want to go into the discussion, the logic of it, but when this sign is positive, every time this sign is positive, it tells you the two numbers have the same sign. Have the same sign. Okay? Every time this stuff is positive, it tells you the two numbers have the same sign, just like here. Okay? When the last sign is positive, the two numbers have the same sign. Either they're both positive or either they're both negative, right? If that sign is negative, it means one of them is positive, the other one is negative. Okay? You see, like here, like this example here. You see the minus 15? This is negative. It means one has to be positive, one has to be negative, right? And that's why we came up with -5 and +3. All right? Okay. So again, you know, in these examples, if we have, so I'm gonna give you some of them. All right, try to do these, please. So the first one, right? What is the number they must add up to?
6 and 7.
Okay, so you say we have 6 and 7. The number they must add up to is what number?
Oh, 1.
1. Thank you very much. I don't see nothing, so I consider it is 1, right? So now what we said, so this sign is negative. It means my two numbers, one of them has to be positive, the other one negative, right? Because that sign is negative. This is a minus sign. My two numbers, one of them has to be positive, the other one negative. Okay? So what's going to be, you just talk about 6 and 7, right? I know one has to be positive, one negative. Which one you elect to put the negative sign on? The 6 or 7?
6.
Exactly. Negative 6, positive 7, right? Okay, so it's going to be x minus 6, x plus 7.
It doesn't matter what order you put them in, right?
No, it doesn't matter. It could be x plus 7, x minus 6.
Okay.
Please do not take the signs lightly. You see, if somebody writes this, they get all the credit. If somebody writes this, they got no credit.
Oh, okay. Yeah.
At all. They get a 0, right? Because mathematically, these two answers are very, very different. Okay? They are really not even close. They are different. So that is why before you write the numbers, make sure you have the right signs, right? Okay, the next one. What numbers are they?
3 and 2.
3 and 2.
Exactly 3 and 2?
No, negative 3 and negative 2.
Negative 3 and negative 2, right? Thank you very much. Negative 3 and negative 2. You see, when you multiply them, you get 6. And you add them up, you get negative 5.
Yep.
Do you agree with me? This is an arithmetic problem here. This is an arithmetic problem, right?
Yes.
If we are very well used to, if we are very well used to the numbers, we come up with the choices like fairly quickly, right? So, okay, so this is going to be x minus 3, x minus 2. Finally, the last one.
1.
Did you find the numbers?
No. 1.
You didn't find the numbers, right?
No.
The only way to break down 7 is 1 and 7, right? Or negative 1 and negative 7. But both ways don't work, right? They don't add up to 3. What we say?
1.
Prime.
Prime, yeah.
Yeah, we say prime.
Gotcha.
We cannot factor this. This is prime or not factorable, right?
Okay.
All right. So now here, if I have another example right here, five x squared, right? Minus 15x minus 50. Okay, look right here. What makes this example different from the one we did before? The one we did in this topic.
I don't have any information about this.
5x squared.
We have 5x squared, right?
Yeah.
Which means here, our technique of looking for two numbers will not work yet, right?
Right.
But I have this one right here. What can I look for, if possible to do? Before I even focus on any particular technique, I can look for the GCF, right? This is a GCF is the very first thing we look for when we do factoring. We have to always check the GCF first, right? Always check the GCF first. What is the GCF here?
5.
The GCF happens to be 5. When I factor the GCF, I put the GCF like this. I put this here. Divide by 5. Divide by 5. Divide by 5. Look what's going to happen. Inside the parentheses, the 5 is gone, right? This 5 is gone. What you have?
X squared.
X squared minus what?
Minus 3.
3x minus 10. Look now, the one in green, this expression in green, does it match the one we did before? It has 1 in front of x squared, right?
Yes.
So we can go ahead and factor it the same way we factor the other ones, okay? Okay, but we were able to do that only after we factor out the 5, right?
Yes.
Okay, so now we can go ahead and try to find those two numbers.
Okay.
What are they?
Negative 5.
Negative 5 and 2.
Negative 5 and 2. Thank you very much. It's negative 5 and positive 2. So x minus 5 here, x plus 2. What I cannot forget in my final answer. In my final answer, what I cannot forget.
The 5.
The 5 in front, exactly. Okay, I cannot forget the 5 in my final answer in front. Okay, so these are the 3 techniques. This one will not be in the test unless you want it to be in the test. It's not. I did not include it in the review.
No.
But I think this topic is very easy, right? So, but you know, we just gonna live up to the review. Okay, so we're gonna stop with the GCF and factoring by grouping. Okay, so prepare for the test next week. Please do not miss the test, right? Everybody, don't miss the test, okay? Look, missing a test or, you know, an assignment is very serious. You know, I have a syllabus in which we have some rules. So when somebody misses a quiz, some people did miss this quiz, like some people miss the quiz. So you get zeros, okay? If you miss the test or a quiz, it has to be a very rigorous justification. Because, you know, you have to know this. I have a lot of students, so it's not a case by case. I have to apply the same stuff to all my students. It has to be a very rigorous, very rigorous justification. So which is documented that we can verify, you know, etc., etc. So missing the test after the fact, and sometimes students do that mistake, is not, as you know, is not like that. When you miss an assignment, some people did the assignment, some people didn't do it. Okay, we can miss a test, you know, of course it happens, but it has to be rigorously justified. Document it, right? If not, we get a 0, okay? And the last quiz, unfortunately, some people didn't do it, right? And the quiz was open for 1.5 days. So something that is open 1.5 days is a lot of, you know, you have a lot of time to do it. If you have 5 questions, you know, 5 questions for 1.5 days, you know, you can do it like within 20 minutes. So don't miss the test. If you know if something is happening, you have to communicate. If something is going to be about to happen, you feel like you won't be able to do the test because something's going to happen. talk to me before the test, and we see if that is a good reason. I am not complicated. If that is a good reason, before the test, we can agree on something, right? But after the fact, the makeup of any assignment is very complicated. It doesn't work like that. The makeup of assignments is very, very rigorously controlled, you know. It's like, you know, we have to follow the rules we put on the syllabus to make up assignments, okay? So don't miss that test. The test is 15%. If somebody misses a 15%, pretty much the semester is over, right? So don't miss, and the test will be done just like test number 1. It's going to be done at the beginning of the class, right? The first hour of the class, we'll have the test for the first hour, and then we're going to take a break, and then we do the second test. We do the class, right? Because unfortunately for this class, we don't have the luxury of, you know, of saying, okay, we're going to just do 3 hours test. No, we don't have that luxury. The time is very tight. We have to keep going with the material, okay? So we're going to do, but since I don't want the material to mix up in your head, right? I don't want that, so we're going to do the test in the first hour. So please, this is the thing. The test will be available on Brightspace next week at 5:45. So if somebody does not connect at 5:45, you are late 5 minutes, it's understandable. 10 minutes, it's understandable. But you cannot be late 30 minutes because meanwhile, I don't know what we were doing. So this virtual stuff, we have to, you know, if somebody does not connect at 5:45 and they come like 40 minutes later, and the test was available on Brightspace, you know, how I know, you know, if they didn't access the test and they were not connected. So you have to be on time, and you cannot be out of the session when the session starts, unless, you know, really something, you know, for instance, I would kicked out, right? But I connected right after. If something really happens, so we're going to try to deal with it, but it has to be very transparent. If really a technological, you know, technical problem really happens, and the students cannot be on Teams in camera, so we will cancel the test and they will take it another day. They will go to the testing center, just take it, right? But we cannot, we have to make the test, you know, as much as we can, very close to the face-to-face case, right? The face-to-face case when you come to the classroom and we give the test. We have to do that as much as we can. So my advice is this: review for the test is very important. You may see this test easier than the first one because you may like the material better. I know the first one, it was all about the lines and people didn't like lines, but whether you like the material or not, try to review thoroughly. And then I have office hours, you know, you have the math center. You can go to the math center to get tutoring. I have my own office hours, you know, I invite you if you have problems, etc., etc. But prepare for this test, please, right? It can be a very easy test. You can have like very good grades in this test. All right, everybody? Yeah. All right, so please, again, you know, don't miss the, you know, the test, right? And for those, yeah, I think that's it, you know. So next week, 5:45 is going to be our test number 2, okay?
And you said your office hours are tomorrow?
My office hours, yeah, my office hours, Wednesday, I have office hours from 10 to 12.
Okay.
Yeah, so please come. If you plan to come, as much as you can, plan to come at the beginning of the hour, right?
Okay.
As much as you can.
Okay.
All right.
Got it.
All right, everybody.